Hello everyone, welcome to my channel Essentials of Electronics. Today we have a new topic on oscillator. Oscillators are electronic circuits which generate output waveforms without any input signal. I would like to compare an amplifier circuit with an electronic circuit. An amplifier is an electronic circuit which receives an input signal along with the biasing voltage VCC and the components present in the amplifier. The amplifier generates an amplified output signal. Yes, this is the output voltage. While an oscillator, without receiving any input signal, only with the help of biasing voltage, the feedback signal, and the help of the components present in the oscillator, it generates or oscillates waveforms. Yes, these are the different types of waveforms. So they generate both sinusoidal waveforms as well as non-sinusoidal waveforms. So oscillators, those generate sinusoidal waveforms are generally called oscillators, and the other oscillators which generate non-sinusoidal, meaning square pulses or rectangular pulses, are called as multivibrators. The circuit comprises of both active and passive circuit elements, which helps the circuit to generate waveforms. Yes, there are some criteria required for oscillation of a circuit. The conditions for oscillations are Barkhausen criterion. Barkhausen criterion, which tells that the total phase shift around the loop as the signal proceeds from input through the amplifier, the feedback network back to the input again. It completes the loop and it precisely is 360-degree, which means A beta is equal to the angle of A beta is equal to 0 degree or 360-degree. A is the voltage gain and beta is the feedback ratio. So the angle of the product of the voltage gain and the feedback ratio should be equal to 0 degree or 360-degree. And the other condition of Barkhausen tells that the modulus value of A beta should be unity. Yes, these are the two conditions according to Barkhausen to satisfy that the circuit will be behaving as an oscillator, and the feedback gain is given by AF is equal to 1 minus beta AB, where A is the voltage gain of the circuit. AF is equal to AV divided by 1 minus AB beta. We have different types of dampings of oscillations. They are as follows. If the modulus of A beta is greater than 1, then the oscillated sine wave will be like this. The amplitude goes on increasing. Yes, if the oscillated wave is of the form modulus of AV beta is less than 1, the amplitude of the wave goes on decreasing. And if the modulus of AV beta is equal to 1, then the generated sine wave will be of the same magnitude. There are different types of oscillators based on the frequency of the signal that it is generating. Yes. So the classification of oscillators goes on this way. The types of oscillators are audio frequency oscillators. Audio frequency oscillators work with a frequency of 20 Hz to 20 kilohertz. Next, radio frequency oscillators. These oscillators generate output waveforms over the frequency of 20 kHz to 30 MHz. Very high frequency VHF oscillators. These frequency oscillators work with the frequency of 30 MHz to 300 MHz. The fourth type of oscillator is ultra high frequency oscillator. Ultra high frequency oscillator, the frequency ranges from 300 MHz to 3 GHz. The fifth one, microwave oscillator. Microwave oscillator. The oscillator ranges from 3 GHz to 30 GHz. The generated sine wave ranges from 3 GHz to 30 GHz in a microwave oscillator. And the sixth category is millimeter wave. Millimeter wave. Millimeter wave oscillator, which generates output signal of frequency, the largest frequency 30 GHz to 300 GHz. These are the different types of oscillators based on the frequency generated. So of these we are in use of these 20 Hz to 20 kilohertz audio signal frequencies and the frequencies from 20 kilohertz to 30 megahertz are used for radio communication systems. So oscillator plays a very important role in our day-to-day life for communication and other purposes. Thank you.